of the day. We have with us Dr. Laviraj Gupta, Pro Vice Chancellor, Lovely Professional University. Let me throw some light on his achievements. He holds a PhD in bioinformatics. He did his MTech in computer-aided design and interactive graphics from IIT Kanpur and BE Honors Mechanical Engineering from MITS Gwalior. Having a flair of endless learning, he has done 40 plus certifications and specializations in IoT, gamification, augmented reality, machine learning from University of California, deep learning, artificial intelligence. His research interests are in the areas of robotics, mechatronics, Internet of Things, bioinformatics, artificial intelligence, and machine learning using TensorFlow and gamification. He has got 85 plus published patents to his back. I welcome you, sir.
Thank you. Thank you.
So over to Dr. Laviraj Gupta for his part of presentation. He'll be discussing about the discipline. Over to you, sir.
Sure. Let me present my screen. Good afternoon, everybody. Let me just present my screen. Let the screen come up, and then I'll talk to you. Good afternoon once again, and for coming 20 to 30 minutes, I'll be talking about the basic fundamental principles and rules behind engineering, actually. Because past, 2 decades, the shift in technology, the shift in engineering and application of science has been dramatic and has been lightening pace. It has happened with a lightning pace. I'll give you certain examples that 2 decades down the line, maybe around 20 years down the line, nobody knew what WhatsApp is. Nobody knew what smartphones are. Nobody knew what exactly the Facebook is. But now the words which I've talked about, like smartphones, like WhatsApp, has become the lifeline. For an engineer who has to begin the career just right away to become an engineer of tomorrow, when I say tomorrow, to become an engineer of next decade, the most important thing which one should understand is the evolution of technology. How technology has changed time and on, so that they understand the transformation or transition of technology from one form to another form to the present form. Because if you do not understand this evolution, you'll not be able to visualize, you'll not be able to foresee, you'll not be able to understand how the technology is going to shift in future. Because you are not going to become engineers to cater to the expectations of the society of today, but you will have to cater, or you'll have to solve the problems of the society for coming 10 years or 20 years down the line. So let me talk about how the evolution has happened. Let us see a very simple example. When I say that people used to move this block of stone from point A to point B, what they did, rather than having a square or a cuboidal block being pushed or pulled, they were creating the rather than having a regular shape, they were creating some kind of a circular shape, so that you all are science, you have done science to an extent. To K-12 level, you have done science. Now, if I have a block which is actually a cuboid, and if I have put it onto a surface, and if I want to move this block the friction would be the sliding friction, and the friction would be onto this entire surface or the bottom of this. The first transition of this evolution was to convert this block into what? Something curvilinear, so that it can be rolled rather than pushed onto the surface. It can be rolled, and the surface area which is actually coming into the contact with the surface is less, so the friction becomes less. Then what they did, that if they do not want to convert this block into a circular or spherical or nearing spherical kind of thing, they used blanks. They used blanks of wood, circular or cylindrical in nature, and then they used to slide this particular block or box over there. Two things. One is they were negating sliding friction, and then the friction was rolling at the surface, and the area of surface which are coming in contact was easier. Then they curated the first instance of wheels. These wheels then got converted into wheels which are better designed, which are more efficient, which are more effective in times to come. And now you see that how this particular wheel oriented innovation got translated, and now you see these wheels which are at the bottom of the world's largest passenger aircraft, that is A380, and these same wheels would be found beneath the spaceship as well. So this is how the technology of present form of wheel has evolved. Until and unless you understand these stages of the development of the wheel, you will not be able to visualize how future wheels are going to be there. This is the basic and primitive intent of having a dialogue with you today. The evolution, if I talk about in terms of time measurement or time keeping, that it started with a sundial, and then came the water clock, then came the sand clock, and then people devised or developed some mechanical, pendulum-based uh, clocks. Now, these clocks, they used to work on the movements of the gears, and they keep track of the precise movement of the gears so that the time can be taken off. And then from the clock, the wall clock, it got shifted to a wristwatch. These are stages of evolution of technology. Presently, you have something called as like this. Now, this is not just simply a wristwatch. This is a whole gamut of a device which primarily act, or one of its function can be display and recording or measuring the time. But that is just 2% or 5% of this device. Rest all, it is capturing the complete clinical data of an individual, recording within itself, sending it to the cloud. From cloud, it is actually getting the analytics done and creating the alerts to an individual if one of the parameters or more parameters are not falling within the range, be it blood pressure, be it actually heartbeat, be it anything. Not doing just that, that it creates alert to an individual who's wearing this. It creates alert to the clinician, the family members of that individual, and it also predicts that what kind of health that individual is going to have in near future. Now, this is how the technology has evolved. That it started with the basic measurement of the time, then various ways and means of measuring the time based on the preciseness, based on the sensitivity of the measurement, and then it came to a handy form of it. Nobody can carry a wall clock all the time, so they innovated a wristwatch. And then further innovation happened, that the wristwatch is not just simply a watch, it is a complete comprehensive device which measures, captures, and records the biological or the clinical parameters of an individual. People are not stopping here. People are really not stopping here. And it is going to evolve now in such a way that you are going to wear a band only. There'll be a band. Now, this band would project the entire screen in front of you at your hand level. And you can actually work with it. I'm not talking about science fiction. This is very well under the proof of concept and prototyping stage, and it will soon be there in the market. Now you may think that why in this particular kind of seminar, why these kind of things are being talked about? Until and unless you understand that how from a sundial to a wristwatch, how that wristwatch got transformed into a complete comprehensive device, and how a better device out of a comprehensive device is curated and is foreseen for the future. If you do not understand the evolution, if you do not learn how it got to the present state of the art, then you'll not be able to work for the future state of the art of that device. I'll again talk about the evolution, that it all started, the communication, I'm talking about the communication. It all started with man-to-man communication, one-to-one, human-to-human communication, and it gave evolution, or it gave pointers to the development of language, be it Tamil, be it Telugu, be it Hindi, be it Russian, be it Japanese, be it French, whatsoever it is. And then what happened? Then came the telephony. This particular telephony you might not be aware about because you are Gen Z kind of, you are millennials. This was used to be termed as PSTN, public switch telephony networks. Then came billboards. Then came televisions. Then came computation and ITES. And now the entire framework is onto the palm of an individual in form of a device called mobile. I'll talk about that. The device mobile, as you see today, was not built as it is seen today. It was built, just a mobile was just built to communicate using wireless transmission protocols. But now this device captures anything and everything. It captures your schedule. It captures it is connected all throughout, and it can give you information in a jiffy at any given point of time. Mobile telephony or connectivity or talking to an individual is just one form of it. It is absolutely analogous to the wristwatch I was talking about. It is absolutely analogous. Now that smart watch is not just simply a wristwatch maintaining time. It is just one of the functions. The innovation, the evolution of the technology has made it what presently it is. And after understanding that how it got evolved to this particular state, then only you will be able to understand the further developments. We call it as industrial revolutions. Now, these industrial revolutions, the very first revolution happened when humans, they used water and steam for mechanized production. Prior to this, it was all hand or human specific production, in which even if you are making gears or whatsoever it is, the humans are crafting and everything. But when people started water and steam for production, then came the first revolution of industry, and we used to call it as industry 1.0. The next revolution came when people started using electric power. Now this transition from industry 1.0 to industry 2.0, this gave rise to one of the biggest revolutions, that is mass production. Prior to this, it was all batch production, it was not mass production, but then it all started with resulting in mass production. Then came industry 3.0. This became the third revolution, wherein people started using electronics and information technology. From electrical to then electronics, embedded systems came into picture, automation came into picture, and then came what we are presently. We are in the present era of industry 4.0, where people are using automation and data exchange. This became possible because of one reason, that the advent or the evolution or the development of cyber physical systems. A physical system, be it maybe be it a wristwatch, which is cyber ready, meaning thereby which is connected. I'll give you the complete framework of the cyber physical systems. These are the computational capability and the computational capacity and the connectivity. These two words became the lifeline of humanity. Each and every device, anything has got the capability of computation. Any device, anything is connected now. Any time and in any context, it can be used or connected. Anyone and anybody is now connected and has got the computing capability. Any service and any business is connected also and has got the computational capacity and capability also. Any place, anywhere, any path, any network. Now, this gave rise to a technology which you as electrical or electronics engineer would really primarily work on for the future. We call it as IoT, Internet of Things, or Internet of Everything, IoE. We call it as Intelligent Internet of Things, IIoT. These are all names, these are all jargons. But basically, it all got evolved from industry 1.0 to 2.0 to 3.0 to 4.0. And now we are not just simply residing on 4.0. I called it as era of industry 4.0. We are just at the industry 5.0 is just around the corner. And it is actually going to club all the things together, be it big data, be it artificial intelligence, be it mechatronics, be it robotics, be it automation, whatsoever it is. The whole gamut is now going to come together with the cyber physical systems. So the awesomeness which has been now practiced, and this is now no more a science fiction. All these things which I'm now going to present are very much available with us. You've got smart homes. Even your TVs, televisions are smart. Your refrigerators are smart. Your washing machines are smart. Your microwaves are smart. And if they all are connected to a hub, you can have a complete home automation system. Past 2.5 years during the advent of COVID and the unprecedented times, we've seen that how healthcare has completely changed. There is a paradigmatic shift in the healthcare, and now it has become so smart that all your bodily or all your clinical parameters are being captured and they are being analyzed in real time. These highways are smart. You can basically, while you are moving on the highways, you can basically bank upon that there is a mechanism, there is a data capture and an analytics which is going on, which can tell you that after 2 kilometers there's a jam, there's a congestion, so you need to take up new route. Smart agriculture is the new form of learning, understanding, and success mantra for professionals. People are bringing loads of embedded systems, IoTs, drones, and whatnot, GIS into agriculture and making it effective, efficient, far better than ever before. Your vehicles are smarter. Even your motorbike, you might be driving a motorbike or a scooty or whatsoever it is smart enough that the spark, if it is a petrol driven vehicle, the spark is going to happen exactly at a place where the efficiency of the drag by the combustion is the best. CDI and those kind of devices are there, which are nearing intelligent kind of things. You have all those smart devices, like you have smart toothbrushes. You have got voice assistants available in form of Siri, Cortana, Alexa, and whatnot. Now, this all became possible because devices are now talking to devices. It all began with human interaction, means a human was interacting with a human, in which languages like English, Hindi, Tamil, Telugu got developed. Then it moved on to human machine interaction. meaning thereby that human was interacting with the machines, how efficiently the human and machine were gelling with each other. But now the era is known as MMI, and this is the new form of living. Machine-machine interaction. The devices are talking to each other. Your mobile phone is going to talk to another mobile phone. The set of mobile phones are going to talk to the various systems together, the various gadgets together. Now this is where the world is moving forward to. The opportunities for you as an engineer, if device-device interaction or machine-machine interaction is happening, you can become a wonderful, data architecture-oriented individual. You can design clouds, you can design fogs, you can design edge devices to give the humans the least latency oriented decision making power. You can be into AI, you can drive home automation or industry automation. You can be ready for industry 5.0, which is just around the corner. By the time you're going to graduate out of this program, the industry 4.0 would be there. You can work on blockchains. As even as electronics and electrical engineer, you need to have an understanding of what cloud is, what edge computing is, what AI, what blockchain is. Then only you will be the engineers of tomorrow. The tomorrow awaits you. It is actually moving on from reality to virtual domain, and there is a concept called mixed reality. Be it actually the uh, the virtual reality, augmented reality kind of things. These are just there. You can have robots which can create algorithms for their decision making without human intervention. They call it as baby AI. Whole lot of opportunities for you as engineers are available in healthcare, are available in agriculture, are available in transportation. The 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 era in times to come would be of engineers who are capable of devising gadgets which are capable and has got the capacity of taking anything and everything on their own. The human intervention would be least. I'll give you an example by this small little clip. And this is a clip of Hyperloop. You might have heard, all of you might have heard Hyperloop. What exactly Hyperloop? Hyperloop is the next generation transportation system. Now, this transportation system will need loads of high-end electronics, loads of high-end electrical systems, because this would work on magnetic levitation, which would need real core electrical engineers. This would be auto-guarded, autonomous. This would be completely autonomous, by driverless kind of navigation, or driverless kind of commuting would be there, needing lots of embedded systems, lots of actually machine-machine interaction. This is going to happen. Thus, in LPU, we have created certain niche. The niches are something like this, that we will make you to think future. We think future. Thus, we have built transdisciplinary research labs. We have a research lab in which the embedded systems can, and they do provide solutions to agriculture farms. They do provide solutions to maybe even fashion designing kind of thing. They do provide solutions to aerospace engineering. We think of technology shift. Thus, we created advanced labs. We created domains, we created advanced labs. We think about expectations, that your expectations and society's expectations from you are going to be completely different than what they are today. So we have best of the faculty members who are actually now with us. We think about your career. Thus, we bring industry into not just simply into your curriculum, but now we are actually having association of the industry to an extent that industry partners or people from industry would deliver in a program at least one course, completely one course every term. So you'll be having at least 8 courses being taught by industry experts, industries like Intel, Texas Instruments, and whatnot. Well, what can be a better opportunity? We'll let you think beyond. So almost all the years of your study, there'll be a course, there'll be an activity, there'll be an assignment for you, which would include, embed in you the experiential learning. Thus, we are all geared up to let you think smart. Now, when we say think smart, uh, you are future smart, you are technology smart, your expectations are met, your careers are very well built, and you think beyond what generally people think of. With all these things actually coming into picture, I'll just showcase some of the products which LPU students, based on all the evolution understanding, based on the foresightedness of future, and based on the labs, the interdisciplinary or transdisciplinary domain interactions, what the students have done during the times of COVID only. They understood that WHO when says that you need to have 20 seconds hand rubbing time while you washing the hands. The students of LPU understood that none of the washrooms would have wall clocks. Nobody goes with a wristwatch to wash the hands. So they created a device in which it can be attached to any of the hand wash dispenser, and you press the hand wash dispenser, it'll actually play a music for 20 seconds. Simple, yet very effective. Now the see Times of India pronounced it quite a lot, and this device is now being sought after by industry so that it can be made as a product. Another innovation, I'm talking about just simply innovation which was done during the COVID times, and which were very effectively taken up as a problem statement by the student. If there is a COVID ward, and if humans are going to go and collect the uh, waste or garbage from there, then it will be vulnerable for them, and they become they become prone to infections. So what they did is they developed smart dustbin, which is voice enabled and which has got pre-fed kind of, it's an intelligent dustbin. So you put it in a COVID ward. If somebody calls, I want to throw my garbage, the dustbin actually travels there, opens up the lid, takes the garbage, and then takes it to the disposing thing. Very well taken up by media, and now the government agencies like DST, the government agencies like CSIO, industries are very much wanting us to share the proof of concept with them so that it can be productized. So it cut above the rest, what we are going to actually instill in you, that we let you learn by doing things. So there'll be a whole load of projects. Your assignment would be activity based. We'll actually we have understood that the projects are the keys. The more you do the projects while your stay or while your sojourn at LPU in your electronics and electrical degree programs, the more you do the projects, the more your CV becomes populated. So we'll let you do projects, and not just simply projects in electronics and electrical. We'll let you do transdisciplinary projects. If you belong to electronics, we'll let you do a project along with agriculture student. We'll let you do a project along with a management student, so that you can do the data analytics, you can capture the data and do the data analytics. We'll let you do the projects with civil engineering or mechanical engineering together, so that you can create autonomous vehicles. We'll let you participate in loads and loads of international and national events, so that you understand what kind of technology, what kind of shift the technology is moving towards to, so that you can be prepared for that. We'll let you have your strong digital presence. When I say strong digital presence, we'll let you do projects, assignments, so that you can showcase it onto your maybe LinkedIn profile or any other professional frameworks like that, so that by the time you graduate, your resume or your professional profile, digital profile is so strong that people should be after you. And finally, on and on, we'll let you co-create the magic. The credo out here, or the punchline out here in LPU is think big, because we have understood that until and unless somebody is going to think big, he'll not be able to think smart. And if he's not going to be able to think smart, he'll not be able to think, dream big. If he'll not be able to dream big, he'll not be able to dare big. And if he's unable to dare big, he'll not be able to achieve big. So we'll let you think big first and think smarter than ever before. Thank you, everybody. I wish you all the very best. The house is now open for any kind of question and answer.
Thank you so much, Dr. Laviraj Gupta. It was wonderful watching you talking on the evolution, the revolution, the cut above, the engineering at LPU, and of course the project were wonderful watching. Thank you so much, sir. Now I would like to invite Mr. Manish Mishra, Chief Innovation Officer, Panasonic India Private Limited. He's with us. Thank you so much, sir, for sparing time for us. Um, in Panasonic, he is responsible for strategic development of innovation and technology while leading the company's innovation hub. He had been chairperson of IBM India IEEE Activities Council and was the part of the program committee as well. He has also worked with HID Global as vice president. So welcome you, sir.
Thank you,
And
Professor Rishi, for having me, and thank you, Dr. Laviraj. Good afternoon to everyone.
Thank you. Good afternoon. Good afternoon.
sir, we would like to have few of the questions which are thrown to us. We would like to have your perspective as industry perspective, as well as the academic institution perspective would be given by Dr. Laviraj Gupta. So can I take up the question, sir?
Okay, sure. Please go ahead.
Yes, please.
So the first question is coming from Karan. He wants to know what are the valuable inputs for the additional courses that we must do, or the certifications we must do as a student to meet Industry 5.0 expectations. So over to
Sure,
Mr. Manish first.
sure. I think a very good question. I think today what is happening is that as an industrialist, we see some of the gaps in terms of what is happening in the industry today versus what are the courses are being taught. So I mean, we recommend people to, I think Dr. Lavira has talked about it, some of this, especially some of the cutting edge technologies. If people can go for the external certifications, that would be really helpful. So things like any certification related to Internet of Things, or VLSI design certification, or embedded systems design certification, and automobile mechanics, depending upon the stream that you are having. Uh, Knowledge of computer programming skills are extremely must, and those are not only relevant for computer science, electrical electronics, but most of the branches. Uh, Industrial automation is going to be one of the key things. Understanding cyber security, understanding machine learning, artificial intelligence, any courses or certifications around that, that would be very, very, useful. Or in terms of, understanding engineering management itself, if somebody has that kind of, certification, that adds, a lot of credits to the overall resume. Uh, Understanding, core of designing, core of design skills, you know, understanding how do you do the architecture of the systems, massive systems. So if any certification in that direction people go for, that would be really, really beneficial for the students, I would say.
Wonderful, sir. I move on to Dr. Laviraj Gupta. Sir, how up to what level we are pushing the students to go for these industry certifications, and how we are doing it?
See, I'll completely second the thoughts of Mr. Manish Mishra, because the more you collect the dots, the more you collect various skills during your journey of BTech or BTech masters or MTech, BTech, MTech, dual degree or whatsoever it is. During your studies, whatsoever you collect in form of certifications would make you a better professional, because we all understand that there may be 1 million of electronics engineers who are going to graduate along with these students. People who have niche or who have gathered the MOS, when I say MOS, number of certifications, will always score better and higher and would be sought after by the industry. I have two observations. I'll answer your question, Professor Rishi, a little later. But you'll have to have a balance of what kind of high-end certification you are working on. You're doing a high-end certification on artificial intelligence given by maybe Stanford University, delivered by Andrew Winch. That's one part of it. But you need to do a certification on the very basic calculus as well. If you do not have the mix of these two things together, you'll be lost somewhere. So if you're doing a high-end certification on IoT, you need to have a certification on basic electronics by Anant Agrawal from edX as well, so that there's a perfect match of the high-end and the very basics, which would weave you into the best of the net. At LPU, we ensure that the curriculum demands these certifications both in terms of credit equivalence. Say, for example, we have already created an equivalence mechanism that this particular course, if you do this MOOC or this certification, the credits are automatically mapped. Be it an NPTEL course, be it a SWAM oriented course, be it a Coursera course or edX course, we have already created. So this gives a student opportunity that rather than doing a course sitting in a class, he or she is doing that certification and earning the credit out of it. The second thing, what we are very particular about it, that we co-deliver courses in line or aligning the content with one of the best MOOCs available on the net. Now, this gives a faculty and a student opportunity to go into a blended mode, that both of them are following the same MOOC and same certification, and the deliberation or discussion in the class is happening over the content. The faculty is actually topping the icing on the cake, but the basic foundational cake comes from that MOOC.
Wonderful, sir. That means we are incorporating and we are promoting the certification to the highest level. Definitely. Thank you so much, sir. The next question goes to Mr. Manish Mishra. Uh, Considering the current scenario changes, what skill set do you expect from a student while hiring in a core ECE company? Yeah.
So I think, of course, when we hire people, we look for the particular domain skills that people come from through their engineering. But one of the things which is extremely important for us or for the industry is that we look for a well-rounded individual, so to say. And what I mean by that is that apart from having your technical knowledge about your subject, whether it is electrical engineering or computer science or mechanical, you know, what kind of soft skills you have developed, you know, what kind of research inquisitiveness you have, you know, interpersonal skills are extremely important working in industry. So communication skills, you know, what kind of communication skills you have, how you persuade individuals, how you work as a team, you know, what kind of creative thinking you bring to the table. And all these things we kind of, you know, judge through number of things, of course, through certain written test, or you know, through our interview process. You know, creativity is extremely important. How resilient you are, you know, how do you handle the pressure when you work in the industry? You always work uh, under certain timelines. So how do you handle the pressure? How do you manage that? So those are some of the soft skills that we look for. Other thing is, theoretical knowledge that is being taught is one aspect of it. But how do we apply that theoretical knowledge into the real life? When we are actually on the shop floor, or when we are actually designing a, printed circuit board, or when we are creating an architecture, what we have learned and how we have applied those knowledges into the real life scenario. That is also equally important for us. So I would say to sum up, we look for not only the technical skills, there are a whole bunch of other skills, attention to detail, pressure management, creativity, leadership in some sense, communication skills, presentation skills, you know, research kind of, skills. When you get stuck in your project work, in your company, in your organization, what do? How do you approach that? What kind of search or research you do? Whom you ask help? So all those kind of, we look for. So I would say it's a well-rounded engineer that we look for.
Dr. Laviraj, I would like to know from you how we are trying to cope up this management issues that is the expectation of the industry.
See, in curricula, as Mr. Manish very rightly said, that he was a well-rounded kind of an individual. So what we have done is we have curated a 13 course framework. We call it as professional enhancement framework. Now that professional enhancement framework would have courses on soft skills, the verbal ability, the analytical ability, and then there are a whole load of communication. See, say for example, in a soft skills course, it's not just simply a course, or a verbal course would not just simply talk about tenses or grammar or things like that. It'll actually let students open out in each and every class and would let speak out what all is happening. That is one thing. The second thing, when I say that the students are developed in such a way that almost all the courses would have activity-based assignments. When I say the assessment would be done on activity-based assignments, the student will have to present and represent what he or she has done. Now, these are certain direct and indirect kind of approaches which we are actually looking to, that how do we develop that interpersonal skills, that leadership skills. If my students are participating in Hacker Rank and Hacker Earth, or maybe in Hackathon, he or she is leading a group, having that flair or learning of being a team builder, being a team leader, or in the initial stages, being a team member. So it is whole gamut of things which we do. The credited course, the inclusivity of interpersonal skills and soft skills during core courses, and participation in the activities or participation in the events for their um, uh, reach out to people, extrovertedness, and instilling that or letting them wear that thinking hat kind of thing, which Mr. Manish was specifically pointing to.
Thank you so much, sir, for giving your point of view on the same. Um, Mr. Manish, industry requirements keep on changing, right? So in future, and let's talk about coming 2 years from now, what changes in the program level or the course level you are expecting, so that we can keep a pace with the placement and the academics.
Yeah, so I think there are a number of things, and of course, uh, one is how do we keep upgrading our curriculum as per the industry, where industry is going, right? And there are a number of ways, we can try to bridge this gap. Is industry and academic. partnership between the schools and the industry, and I think some of it is already happening. Dr. Laviraj knows that I'm also part of the lovely Professional University College of Mechanical Engineering Corporate Advisory Board, and some of these things are getting addressed through those platforms. So first and foremost is cooperation and co-working with the industry for academia and the industry together. So it's a two-way road actually. There is something for the academia and there is also something for industry, because if we work closely, then we get future ready individuals who are from the day one hireable and apply their knowledge to produce from the day one, instead of going through lengthy training process which costs a lot of money and effort and time for the industry also, which we kind of do it today for 6 months or 1 year training. So in my thinking, of course, there are many approaches that can be taken, and some of those are also being discussed with Dr. Laviraj, myself, and other, corporate advisory board members. But things like, having longer internship in the industry, so that students get hands-on experiences, or industry kind of, throwing the real-life problems, which can be incorporated in the curriculum as part of the laboratory work, or lab project or something, you know trying to do certain seminars by industry people to come to the all the colleges and kind of do that, maybe having a guest faculty from the industry to teach one of the courses, maybe advanced technology courses, some of these like IoT, or design skills, or AI, artificial intelligence, data analytics, also understanding what are the real gaps today, and then carving out a very realistic approach and strategy for that. Part of it also starts with having the faculty also being trained. So what is happening today in the industry and how well aware our existing faculty is. So upgrading our faculty will also upgrade our students. So that is another thing. Initiating certain task force, or having student organizations who interact. I would say longer internship period with the industry. Industry throwing up a lot of real life problems at the students, and they are become part of the projects. So those are the few suggestions that I will kind of put on the table for now. But I think Professor Rishi, I'm glad you asked that question, because I, along with Dr. Laviraj and other board members, are very actively working on some of these aspects, which are relevant for you and which are relevant for us as industry, for you as an academician, and for us as industrialists, and also for the student, because ultimately it's the student who is coming out a well-rounded individual, well trained, and having knowledge about what is happening in the industry from the day one. So that's how I can sum it up.
Thanks so much, Mr. Mishra. And Dr. Laviraj, would you like to add on to this? How we are doing this?
As Mr. Manish pointed out very rightly, that we are working very closely with the industry, because now we have corporate advisory boards in place, and people like Manish, people like stalwarts with years and years of experience in building up businesses, kind of thing, are now with us. I'll say they're guiding us that how do we take this interaction to a level wherein the time to productivity of individuals is reduced. My thought here would be, I have a one-liner thought, that we just simply do not believe in just developing the skill set, but we also believe in developing the will set. Because Mr. Manish is primarily talking about skill is one part of it, but will is another part of it. That will cannot come until and unless you are rounded, but you are also grounded. B, you know the basics and you are ready to unlearn and relearn what the technology wants. And C, the kind of moss or the kind of gravity which you gather during your program is completely ensured by industry inclusivity, by industry's participation, And Mr. Manish very rightly said that it is the need of the hour that faculty goes to industry for a sabbatical. And Manishji, let me put forward and tell you that this midterm examination, during midterm examination, for 1 week, we have sent our faculty members to industry for sabbatical. They were there, they belong to mechanical, they belong to electronics, they belong to computer science, and they have gone to their relevant industry, have been there. And believe me, their perspective about engineering and about, uh, uh, professionalism has completely changed.
That's excellent. Very good. Excellent.
Thank you so much, sir, for sharing some of the nice things that the attendees must know what is happening in the university and how we are collaborating with the industry, how closely we are working. So I see so many attendees over here, Muhammad Afsal, Chaitanya, Pankaj, Daljit. In case any of the attendees would like to talk to the experts directly, one or two we can take quickly. If you raise your hands, I would be connecting you with the experts directly. Quickly, you need to be, all the attendees, you need to be really quick in raising the hands. Through the interface, I'll be giving you the chance to talk to the experts directly. Kamal is here, Danveer Mandal, Ashok. So you see people coming from core industry. Yeah, Rushi Vadapalli. Rushi, I have given you the rights. Please unmute yourself and take up your question. Rushi. Yeah.
Good evening, sir. My name is Rushi. I just have a question. Sir, I just completed my 10th class and I would like to join for diploma program in CSE Computer Science Engineering. As I would like to ask, is there any hackathons or any projects given to the diploma students in the second year and first year when we join?
I request Dr. Laviraj Gupta. Yeah.
From the very first semester, we ensure that your experiential learning begins from the very first semester. It's not about second year or something like that. You'll
Yes,
have
sir.
the courses on basic electronics or maybe C programming or Python programming kind of courses while you're doing your computer science CS diploma. And
Yes, sir.
that would be assessed on some small minor projects which you do.
Yes,
So
sir.
the curricula, even if it is diploma's curricula, it is quite skill enabling, and
Yes, sir.
you'll be given. And by the end of your diploma, you'll be given an opportunity to showcase your all the work or best of the works during an event which we call it as Explorica, wherein students actually uh, share their best of the works in front of the industry experts.
Oh, nice. Yes, sir.
Can I take up one more question before we sign off, sir?
Yeah, please.
Yeah, we have Vijay Raghavan. He's raised his hand. Vijay, I have given you the rights. Please unmute yourself.
Yeah,
Yeah.
thank you, sir. Thank you for just giving me an opportunity. Very sorry that I just joined a bit late, so I don't know my question is being discussed earlier. This is for my son. I'm just like asking. So I really want to choose between. I mean, there is a confusion with us, like between this electronic and communications and electrical engineering and this triple E, because like currently, if you see, due to this electric vehicles are just like is the talk of the town. So there is a confusion that which area that I really like need to put him and which is really a job oriented kind of course.
Mr. Manish, would you like to begin the dialogue with your point of view?
Yeah, actually, again, I think each and every course has a certain speciality, and I may not be an expert, so I would request Professor Rishi or Dr. Laviraj to answer that. But from our perspective, we should understand what exactly the student is looking for. because there is a slight difference between, let's say, computer science and computer engineering. And some universities club these two together, and computer science and engineering. Then there is a very thin difference between electronics and communication. And basis which, their curriculum is, or their course structures are decided. So I'm sure you would get the structure of each semester and courses offered, basis which the students could take a call, which stream they want to go, because there is a very thin difference between electronics and communication. Electrical, there is a huge difference, because then you go onto the power side of it. Electronics is mostly on the, you end up doing circuit designing, electronic automation and all that. And computer science, computer engineering also, there is slight difference, but I will let Dr. Loviraj and Dr. Professor Rishi to kind of clarify that.
See, my point, because you're talking about your son, my point here would be that rather than actually looking to the career prospects, see, career prospects are equitable in all the branches. If an individual is skilled, and if an individual has the transdisciplinary bent of mind, opportunities are in abundance, whatsoever discipline it may be. The only thing is, leave it to the student that what excites him more, that soldering a circuit, using Arduino or Raspberry Pi to create a blinking kind of a LED, that excites him more, or to install a miniature circuit breaker based on the load of the room excites him more. Because we need to understand, there's a whole load of gap that we do not ask the children that what makes them exciting, what gives them the goosebumps while they are doing. He's more excited to open up a digital clock and look to it, or television and look to it, or he's more excited to see what kind of wiring is there in your house, because the career begins there. If he's more excited into embedded systems or circuits, and he looks to the videos of how wristwatches or maybe how smartwatches work, what is the basic principle behind communication, then electronics would be his forte. But if he's more interested, as Mr. Manish was very wonderfully talking about, he's more interested in power distributions, he's more interested in motors, and he's more interested in what the wirings or wiring diagrams, he's more interested in transformers and things like that. Electrical would be something great. There is no dearth of opportunities in any of the careers, in any of the branches of engineering. The only thing is, if a student has chosen that particular branch by virtue of his passion, not by virtue of somebody saying that electronics is in demand nowadays, we need to do away with this. Mr. Manish, would you agree to what I say?
Yes. I think what you have said, Dr. Loviraj, and I would second that there is no lack of opportunities across any of the branches today. And the way India's growth story is kind of coming up, whether it is electronics, electrical, computer science, mechanical, civil, because infrastructures are also booming. Make in India, manufacturing sector booming up, infra booming up. Digitization happening at a rapid pace. So all the branches will have huge opportunity. It boils down to, as an individual, what the interests are, and then also having certain cross disciplinary skills. For example, today we recommend all branches to have programming knowledge. Not just limited to computer science. Understanding what is IoT, what is cloud, what is data analytics. At least if you're not able to go deeper, but at least having some knowledge about it, that those are very essential. So it will bind on to individuals' interest based on the curriculum that is described under each of those, and then take a call. But from opportunity wise, there is no lack of opportunity.
So much, sir, and I hope your words, your wisdom might have given a lot of confidence to Mr. Vijay Raghavan, who is looking for a career in ECE or ECE or CSE or any other branch. Thank you so much, sir. With this, I would like to sign off by saying, experts, your years of research, your depth of understanding the topic, and your ability to present the topic in such an interesting way produced one of the most wonderful afternoons for all the attendees. On behalf of all the attendees of this webinar, I want to thank you for your insightful presentation. Hopefully, the attendees also found this webinar to be valuable enough and will be able to utilize the information provided by the experts to take a better decision regarding their careers. I'm obliged and once again thankful to Mr. Manish Mishra from Panasonic and Dr. Laviraj Gupta, Pro Vice Chancellor, Lovely Professional University, for strengthening this platform. Thank you so much, sir.
Thank you. Thank you, everybody.
Thank
Thank
you.
you, Mr.
Thank you,
Manish. Thank you. Thank you.
Thank you.
Professor Rishi.
Bye-bye.
Bye-bye. Please.